So this is the practical exam 1 for May 2010. And we want to just focus on writing formula for the complexes formed in the different observation tests. So this is on page 7, sorry. And they ask us to deduce the formula of the complex formed in test 2, test 5 and test 6. So we need to flick back to page 6 to have a look at what's happening in test 2, 5 and 6. So here I have the observation tests and I have written in what the observations are. Not in just as much detail as the mark scheme, but the most important points. And so we're looking for the formula in test 2, test 5 and test 6. So by the end of it, you will have deduced that we have copper ions in our salt. And so what we're doing in test 2 is we're just adding water. And so what's happening is water acts as a ligand, and so we're forming our hexa-aqua complex. So we've got a Cu with 6 waters, and that's the case for adding water to any metal cation. It forms its hexa-aqua complex. So it's the copper with the 6 waters, and then to show it's complex we have our square brackets around it. And then to work out our charge we need to think of the charge of the cation. The metal cation is Cu2+, and then think of the charge of our ligands. Our ligands are water and they are neutral, so they don't contribute to the charge. So the overall charge of the complex is 2+. And that's how we deduce the formula of that. Okay, let's go down to see what we're doing in test 5. On test 5 we are adding ammonia dropwise, and then until it's present in excess, and we find that it's a deep blue solution. So what we're doing is we're taking our solution, our hexa-aqua complex, and we're adding ammonia. And once it's added in excess, what happens is some of those ammonia ligands replace the water ligands. But we know with copper that it doesn't replace them all. It only replaces some of them. And so I'll do this in a nice deep blue colour. And what happens is 4 ammonias take the place of 4 waters. So what we end up with is copper with 4 ammonia ligands and 2 water ligands. Again, thinking about our charge, copper has a charge of 2+, and ammonia and water are both neutral, and so the charge again is 2+. So with copper you need to remember in particular that on excess of ammonia, ammonia replaces 4 of the water ligands. Finally then, test 6, you're asked to explain the green solution and the complex formed in test 6. And what we're doing with concentrated hydrochloric acid. Well, think of a hydrochloric acid. What ions is it made up of? It's made up of H+ and Cl-. So hydrochloric acid, which has the formula of HCl. And it's these Cl- ions that act as ligands in our complex. And so going back to our hexa-aqua, what we've done is we've taken, for each of these, we're adding it to solution of A. So we're adding this into our hexa-aqua complex that we deduced up here. And what the chloride ligands do is they have the effect of again replacing the water ligands, and so we form a copper chloride complex, a chloro-copper complex to be more precise, and we'll do this in a nice green colour. And what we find is due to the size of the chloroligands, there's actually only 4 chloroligands. And again I need to think of the charge. So I have copper 2+, and then I have 4 chloroligands which have a charge of minus, as we can see here. So we've got 2+, and then 4 minus. So that has the overall charge of 2 minus, and I show that outside my brackets, and that's how I work out what's happening there. So in terms of if we were asked to write an equation for that, for this process, what we've started with is our hexa aqua complex, so Cu brackets H2O6 2 plus. We've added in 4 chloroligands, and we end up with our chloro complex, and our 6 waters have been replaced, so we can just write them on at the end. So if you're asked to write an equation, you just on the left hand side you write the ligands that are coming in, and then on the right hand side you've got your new complex that you form and with your replaced ligands, and then the old ligands are on the right hand side as a product, free in the solution. So it's now the chloroligands that have come in and bonded with your metal ion, and the water ligands are now free in solution.